This video is for section 1.1 in your textbook on numbers. And the first thing we want to take a look at is identifying the different number sets. So let's see. For the most part throughout your life, you have been dealing with real numbers. And the real numbers sit inside this box here. And the real numbers consist of some different sets. So let's first take a look at the ones that I have right inside here, the natural numbers. They are the smallest set of real numbers. They consist of what we call counting numbers that begin at 1 and proceed in the positive direction. So 1, 2, 3, and so on forever up to infinity. The next set outside of natural numbers is the whole numbers, and the only difference is now the inclusion of the number 0. The whole numbers begin at 0 and proceed in the positive direction with only counting numbers 1, 2, and so on. The next set is the integers. Integers are numbers that begin at minus infinity and proceed towards 0, come to 0 and proceed in the positive direction. And they don't include any portions between these values. So they are like counting numbers, but they include the negatives. And then we get to the rational numbers, and the rational numbers are numbers that will include values between integer values. So they include fractional values. And rational, if you think about the word ratio, which is right inside there, they are a ratio of one number over another. And actually, usually we write fractions with one integer over another. So they consist of one integer over another. Any number that can be written as one integer over another one is called a rational number. They don't always look this way to us, and I have not made those negatives, I'm just pointing to them. They might not always look like a fraction like this one, but it can be written as a rational number, one ratio or one integer over another. They can be positive like this one, they can be negative like this one. Outside of this set is the irrational numbers. These are numbers that cannot be written as one integer over another, all right? Cannot be written as one integer over another. When we look at their decimal values, they are non-repeating decimal values, no pattern to them. Pi is irrational, it goes on forever with no particular pattern. Outside of the real numbers, we have what are called the imaginary numbers. Imaginary numbers are when we have the square root of a negative value. And if you think about it, when you look at the square root of a number, you are looking for what number multiplied by itself is equal to whatever value is in here. And we don't have any real number that when it's multiplied by itself becomes a negative, because a positive multiplied by a positive gives us a positive. A negative multiplied by a negative gives us a positive. And so we will never result in a negative number. These we will not be dealing with in this course. All right, you may see it in another course. Next, let's take a look at fractions. Fractions are the rational numbers, and they are a way of describing a portion of a whole number. And so if I have this circle divided into 8 equal sections, okay, these are 8 equal sections. And I would like to represent a certain portion of that. For example, if I shade in 5 of those 8 equal sections. All right. So now this fraction is represented by 2 values. The number that the whole is divided into is the denominator. We have 8 equal sections. The number that are shaded is the numerator, 5 of the 8 equal sections. So this diagram represents 5/8 of the whole. If you happen to be looking at the unshaded part, well, it would be 3/8. And as a side note, if we add those 2 fractions together, they are both in eighths, so they can be added. We would add 3 plus 5, keep the 8s, and it becomes 8/8. Well, 8/8 is equal to 1 whole, and that the 2 together represent 1 whole. All right, so some terminology to go with fractions. A proper fraction is when the numerator is less than the denominator, as in our 5/8, or for example, 2/3, 4/5. All of these are proper fractions, and they represent values less than 1, okay? Represent values less than 1. Improper fractions are when the numerator is greater than the denominator, something like 10/3 or 5/2, okay? These represent values greater than 1. A mixed fraction is when we have a whole number and a proper fraction, something like 2 and 1/3, 5 and 3/4. All right. At some other time, you may learn how to convert between these two, but not in this video, okay? Conversions is helpful. Common fractions are fractions that have the same denominator as in our 8s, all right? So our 3/8 plus 5/8. We keep the 8 and we add the numerators. In order to do addition and subtraction, you must have common fractions. You cannot add fractions of different denominators. The pieces of the whole are different sizes then, and they cannot be added. Next, we will take a look at the number line. So the number line consists of all numbers in the real number. These are real numbers. And all numbers from -infinity to +infinity would sit somewhere along the number line. With 0 sitting in the middle, we often call this the origin. If we move to the right from 0, we move in a positive direction. If we move to the left on the number line, we are moving in a negative direction. Notice that from 0, if I go 1 space, I'm at -1. If left, right? And if I move right, I'm at +1. So therefore, in between 0 and 1 is an example here, 4/9. It is a proper fraction with the numerator less than the denominator. It represents a value, between 0 and 1, almost halfway, but not quite. Another example, 1.7 lies greater than 1 but less than 2, and so it sits just to the left of 2. Pi is another example, approximately 3.14, so it's just to the right of 3 on the number line, just a little greater than 3. In the negative side, pi over 2, half of 3.14 roughly, is between -1 and -2. Minus 26 over 5 is just a little bit less than -5. So it is just to the left of -5. When you are adding and subtracting signed numbers, it's helpful to picture the number line. Think about where you are beginning on the number line and whether your number should be increasing or decreasing. It may be helpful before the course begins for you to work on some of the practice of mathematical operations with signed numbers. So practice addition, subtraction, multiplication, and division with signed numbers. Absolute value is something that sometimes comes up in a formula, and it is shown by two of these straight line bars around a number. For example, absolute value of -3. Absolute value represents the distance from 0. So there are times when it doesn't matter what direction you go from 0, but just the space is important. And so if we look at, we'll draw ourselves a little number line. And the space that -3 is from 0, or the distance, is how many units? 1, 2, 3. So it's only 3 units from 0. So this is actually equal to 3. The absolute value of +3 is the space that it is from 0. So it is 1, 2, 3. If we count the spaces, 1, 2, 3. It's 3 units from 0 as well. So basically what an absolute value means is to turn the value positive. So this is a negative number, but its absolute value is the same value but positive. You might sometimes see operations within absolute value signs. You should evaluate what that number is inside the absolute value signs first. 2 subtract 5. If I sit at 2 and I subtract 5, subtract means to go in the negative direction. And we go 1, 2, 3, 4, 5. I land on -3. The absolute value of -3 is equal to 3. Okay, so please don't mistake these straight line bars for brackets. They are different. They are absolute value symbols, and you should take the number as a positive value that is inside it. The last thing in this unit that we want to take a look at is reciprocal values. The reciprocal of a number is 1 divided by the number. So, for example, if I have the number 4, the reciprocal of 4, so, is 1 divided by 4. So the reciprocal of 4 is 1/4. Another example, if I have 2/3, the reciprocal is 1 divided by 2/3. And if you think back to working with fractions, way back when you learned them in public school, you were told instead of dividing by a fraction, you should multiply by its reciprocal, right? So we would take our 1 and multiply by the reciprocal of 2/3 is to flip it over also, 3/2. So this is equal to 3/2. And in fact, we could have done that just by flipping the fraction, but I just wanted to show you that it also means 1 divided by the number. Sometimes we have to find the reciprocal of a decimal value. When we want to find the reciprocal of a decimal value, it is helpful to know how to do it on your calculator. So you should take a look at your calculator and find the reciprocal key. It will look like either 1 over x or x to the minus 1. Those are the standard value or ways to represent reciprocal on a calculator. It may be a full function or it might be the second function. So it's important for you to get to know your calculator in this case. For example, find the reciprocal of 1.25 using your calculator. And to do that, you will punch in 1.25 and hit your reciprocal key. On my calculator, it's a second function, so I have to use my second function key, and mine looks like x to the minus 1, and I should see 0.8. If your calculator displays it as a fraction, then you will also possibly see 4/5. Okay, just practice one more. Find the reciprocal of 3.2 using your calculator. Pause the video and give it a try. So the reciprocal of 3.2, you should see, so 1 divided by 3.2, 0.3125. You can also find that by doing 3.2, second function if it's required for your calculator, x to the minus 1, 0.3125. If it displays it as a fraction, you will see 5/16. Some calculators do this, not all of them do. Okay, so it'd be helpful to be able to find reciprocals of values without having to delete it and then punch in 1 divided by, and that's where using the reciprocal key in the future will be helpful for you. All right, thanks for watching, and next we'll be moving on to 1.2 in the text.